Hello everyone!
This is the story of seedless fruits, and these are the presenters for today. Our video are mainly about what makes a seedless fruit seedless, so there's going to be a lot to learn today.
Let's get started.
To take a step way back, many seedless fruits result from a genetic mutation that once discovered can be propagated through grafting or cuttings. The first one, the navel orange. The navel orange comes from a single branch on a tree that was discovered in the early 18,000s. The seedless navel oranges were propagated through grafting and beloved by many. By the late 18,000s, navel oranges were grown commercially in Southern California and remain one of the most popular citrus fruits today. The seedless grapes. The seedless grape is thought to date back to ancient Rome and was first introduced to the US in the mid-1870s under the name Thompson. Most seedless grapes today derive at least in part from the Thompson variety. The seedless watermelon. Watermelons originated in Africa as small, tough, bitter fruits, but centuries of selective breeding have resulted in the sweet melons we know today. It was discovered that doubling the number of chromosomes in a normal watermelon will result in a seedless 3 sets of chromosomes watermelon. Last but not least, the seedless banana. Seedless bananas have a similar history going back several thousand years. Seedlessness started as a natural mutation from heavily seeded wild banana. Selected breeding over many years has developed the sweet, seedless fruits we enjoy today.
You might wonder, how do seedless fruits created, and does it occur naturally?
Most original seedless fruits were created using the parthenocarpy process, by which fruits are produced without the process of fertilization of ovules. A parthenocarpic fruit does not have any seed. They are also called virgin fruits. There are two types of parthenocarpy, which is natural and induced. Let's focus on natural parthenocarpy first. Natural parthenocarpy is the production of seedless fruits without any special treatment and are produced from the ovaries in the absence of pollination and fertilization. Some of the example includes grapes, pineapples, and orange.
The other type of parthenocarpy is induced parthenocarpy. Induced parthenocarpy normally occurs when seedless fruits are produced from the ovary by exposing the flower to a special treatment. As the name implies, induced parthenocarpy is an artificial process that produces seedless fruits. This type of process are divided into two parts. Some plants, known as stimulative parthenocarpy, require pollination or another form of stimulation for parthenocarpy to occur. For example, seedless watermelon. Vegetative parthenocarpy refers to plants that do not require pollination to produce parthenocarpic fruit, but the parthenocarpy is induced into by applying growth hormones and pollen extracts. For example, seedless cucumbers. Auxins and gibberellins are important plant hormones that play a major role in plant growth. They are natural phytohormones but can also be added from the outside. If you only apply the hormone outside of the flower's pistil, the ovary will still be stimulated by the hormone source. The fruit is from without natural pollination and is therefore a normal but seedless fruit.
There is also stenospermocarpy, which is a type of parthenocarpy where fertilization occurs and the seed begins to develop but eventually aborts, leaving behind a noticeable seed trace. Seed traces vary in size depending on how far seed development progressed before the abortion and are generally soft enough. Breeders of seedless grapes remove developing seeds and growing them into plants using tissue culture technique. Stenospermocarpic varieties have the advantage of growing full-size fruit, while the parthenocarpic seedless grapes tend to be smaller.
Thanks to this method, the creation of seedless fruits are continued to different ways of cultivation.
The first type of cultivation is grafting. In the grafting process, a branch from one tree is cut and attached to another fruit tree. If the graft takes root on the new tree, it will begin to grow using the nutrients provided by the parent tree. For example, grape and navel oranges. Some fruits clones, like navel oranges, aren't good at self-pollination, so they are planted in the large orchids. When they are surrounded by the genetically identical copies of themselves, this causes them to produce parthenocarpic fruit. Another cultivation technique is root division. It involves digging up and severing a portion of the root system of a plant and replanting it. There is also a cultivation using rhizomes. Mainly used by banana, rhizomes are stems that grow underground which then shoot up off the ground to produce what are known as banana pups. The pups are taken off of the mother plant and transplanted to create a new plant.
Here comes the special fruit, watermelon. It is special because the process of producing its seedless counterpart is complicated. Seedless fruits can't produce on their own, and watermelon vines can be easily grafted to form new plants. Watermelon and banana are polyploidy and can become seedless if they have 3 sets of chromosomes. Triploid organisms occur naturally or can be developed by crossing 2 sets of chromosomes with 4 sets of chromosomes to produce a triploid. In the case of watermelon, pollination needs to occur for fruit to develop fully, and since triploid pollen does not germinate, diploid varieties are interplanted to provide viable pollen to induce fruit without complete seed development. The white seed traces are readily visible in watermelon.
Here are the benefits and drawbacks of seedless fruits.
There are some clear advantages of seedless fruit varieties. The main advantage is convenience. There is no need to remove the seeds before eating. You can pop the seedless grapes right in your mouth and eat slices of seedless watermelon without having to pick out any seeds first. Second one, it is easy to eat. Fruits will be easier to eat as a snack, putting into fruit salads, blending into smoothies without having to scoop out the seeds first. Seedless varieties tend to be kid-friendly options. The lack of hard seeds reduces the risk of choking and makes fruits easier for little ones to chew and digest. Seedless fruits also tend to have a more uniform, visually appealing and attractive appearance, makes them preferable for use in commercial contexts like restaurants, food displays, or grocery store product sections where aesthetics matter. However, there are some potential limitations to consider. Some argue that seeded varieties have a more concentrated intense flavor, but certain seedless watermelon varieties are criticized for being less sweet and flavorful. Other than that, seeds provide an extra nutritional boost by offering healthy minerals and phytochemicals. The pulp remains nutritious, but overall nutrient density per serving may be slightly reduced. The smoothness of seedless fruits appeals to many, but for some, the variation in texture provided by the crunch of seeds is preferable. Seedless product also tends to be marketed as a premium options and priced higher at the supermarket due to complex growing techniques required. Lastly, widespread single varieties reduce overall crop biodiversity compared to traditional produce grown from genetically diverse seeds. Disease susceptibility increases without diverse genetic strains.
To conclude, the study on seedless fruits has highlighted their significance in meeting consumer preferences for convenience and improved eating experiences. Through advancements in breeding and genetic engineering, seedless varieties can offer commercial benefits and addressing potential environmental concerns. While challenges exist, ongoing research and technological innovation promise further improvements in seedless fruit production, contributing to the evolution of agriculture and enhancing the availability of diverse, desirable fruit options for consumers.
Thank you for watching.
Bye!